The sun, the center of attention. Where is the sun located? The sun rises every day in the east. It appears to travel across the sky in a predictable way before it sets in the west. The apparent motion of the sun led many early astronomers to believe that the sun moved around the earth. In the early 1500s, astronomer Nicholas Copernicus developed a different model. He proposed that the earth revolved around the sun. The sun is the center of the solar system. We now know that Copernicus was correct. The sun is located at the center of the solar system. The solar system includes the sun and all of the objects that travel around it. Planets, dwarf planets, asteroids, and comets revolve around the sun in paths called orbits. Earth is one of the 8 planets that orbit the sun and is the 3rd planet from the sun. The sun is by far the largest and most massive object in the solar system. Its gravitational attraction keeps the other objects in the solar system in orbit around it. The sun is located in the Milky Way galaxy. The sun looks small from Earth because it is located so far away. In the 1700s, Edmund Halley found a way to calculate the distance between the Earth and sun. The distance is almost 150 million kilometers. This discovery gave scientists a model with which to determine distances between objects in the solar system. All of the stars you can see are much further away than the sun. Like the sun, they are part of the Milky Way galaxy. Hundreds of billions of stars make up the Milky Way. Our solar system is located in a partial spiral arm of the Milky Way, about 25,000 light years from the galaxy's center. The sun is located in the local group. The Milky Way galaxy is one of possibly 100 billion or more galaxies in the universe. As scientists gather data from great distances in the universe, they discover that galaxies are not spaced out evenly. They are found in groups or clusters. The Milky Way is located in the local group. The local group is a cluster of about 30 galaxies that is approximately 10 million light years across. The Andromeda galaxy is part of the local group. It is the closest large galaxy to the Milky Way. The local group is the part of the universe that astronomers know the most about. Here comes the sun. What are the physical properties of the sun? Since early in human history, people have marveled at the sun. Civilizations have referred to the sun by different names. Gods and goddesses who represented the sun were worshipped in different cultures. In addition, early astronomical observatories were established to track the sun's apparent motion across the sky. By the mid-19th century, astronomers had discovered that the sun was actually a hot ball of gas that is composed mostly of the elements hydrogen and helium. Scientists now know that the sun was born about 4.6 billion years ago. Every second, 4 million tons of solar matter is converted into energy. Of the light emitted from the sun, 41% is visible light, another 9% is ultraviolet light, and 50% is infrared radiation. Perhaps the most important of all, without the sun, there would be no life on Earth. The average distance from Earth is 149.6 million kilometers. The diameter of the sun is 1,391,000 kilometers. The average density is 1.41 grams per centimeter cubed. Period of rotation, 25 days at the equator, 35 days at the poles. The average surface temperature is 5,500 degrees Celsius. The core temperature is 15 million degrees Celsius. The composition is 74% hydrogen, 25% helium, and 1% other elements. What is the structure of the sun? The composition of the sun and Earth are different. However, 2 bodies are similar in structure. Both are spheres, and both have layered atmospheres and an interior composed of layers. In the middle of the sun is a core. This is where energy is produced. From the core, energy is transported to the sun's surface through the radiative zone, and the convection zone. The sun's atmosphere has 3 layers: the photosphere, the chromosphere, and the corona. The sun's surface is the photosphere. Energy escapes the sun from this layer. The chromosphere is the middle layer of the sun's atmosphere. The temperature of the chromosphere rises with distance from the photosphere. The sun's outer atmosphere is the corona. The corona extends millions of kilometers into space. The corona is the outer atmosphere of the sun. Temperatures in the corona may reach 2 million degrees Celsius. The chromosphere is the middle layer of the sun's atmosphere. Temperatures in the chromosphere increase outward and reach a maximum of about 20,000 degrees Celsius. The photosphere is the visible surface of the sun. It is the layer from which energy escapes into space. The photosphere has an average temperature of 5,500 degrees Celsius. The convection zone. The convection zone is the layer of the sun through which energy travels by convection from the radiative zone to the photosphere. The radiative zone is the layer of the sun through which energy is transferred away from the core by radiation. The core. The core is the very dense center of the sun. The core has a temperature of 15 million degrees Celsius, which is hot enough to cause the nuclear reactions that produce energy in the sun. Let's get together. How does the sun produce energy? Early in the 20th century, physicist Albert Einstein proposed that matter and energy are interchangeable. Matter can change into energy according to his famous equation E equals mc squared. E is energy, m is mass, and c is the speed of light. Because c is such a large number, tiny amounts of matter can produce huge amounts of energy. Using Einstein's formula, scientists were able to explain the huge quantities of energy produced by the sun. Scientists know that the sun generates energy through the process of nuclear fusion. Nuclear fusion is a process by which two or more low-mass atomic nuclei fuse to form a heavier nucleus. Nuclear fusion takes place in the core of stars. In stars that have core temperatures similar to the sun's, the fusion process that fuels the star starts with the fusion of two hydrogen nuclei. In older stars, in which core temperatures are hotter than the sun's, the fusion process involves the fusion of helium and carbon. By the fusion of hydrogen into helium. The most common elements in the sun are hydrogen and helium. Under the crushing force of gravity, these gases are compressed and heated in the sun's core, where temperatures reach 15 million degrees Celsius. In the sun's core, hydrogen nuclei sometimes fuse to form a helium nucleus. This process takes 3 steps to complete. This 3-step process is illustrated below. Most of the times, when protons are on a collision course with other protons, their positive charges instantly repel them. The protons do not collide, but sometimes one proton will encounter another proton and at that exact moment turn into a neutron and eject an electron. This collision forms a nucleus that contains one proton and one neutron. The nucleus is the isotope of hydrogen called deuterium. Deuterium nucleus collides with another proton and forms a variety of helium called helium-3. Then, 2 helium-3 nuclei collide and form helium-4 nucleus that has 2 protons and 2 neutrons. The remaining 2 protons are released back into the sun's core. This entire chain of fusion reactions requires 6 hydrogen nuclei and results in 1 helium nucleus and 2 hydrogen nuclei. There are approximately 10 to the 38th power collisions between hydrogen nuclei taking place in the sun's core every second, which keeps the sun shining. Mixing it up. How is energy transferred to the sun's surface? Energy is transferred to the surface of the sun by 2 different processes. Energy that is transferred from the sun's core through the radiative zone is transferred by a process of radiation. Energy that is transferred from the top of the radiative zone through the convection zone to the photosphere is transferred by the process of convection. Energy flows from the sun's core outward to the sun's surface by radiation, and convection happens continuously. By radiation. When energy leaves the sun's core, it moves into the radiative zone. Energy travels through the radiative zone in the form of electromagnetic waves. The process by which energy is transferred as electromagnetic waves is called radiation. The radiation zone is densely packed with particles such as hydrogen, helium, and free electrons. Therefore, electromagnetic waves cannot travel directly through the radiative zone. Instead, they are repeatedly absorbed and re-emitted by particles until they reach the top of the radiative zone. By convection, energy that reaches the top of the radiative zone is then transferred into the sun's surface. In the convection zone, energy is transferred by the movement of matter. Hot gases rise to the surface of the sun, cool, and sink back into the convective zone. This process, in which heat is transferred by the circulation of movement of matter, is called convection. Convection takes place in convection cells. A convection cell is illustrated on the opposite page. Convection cells form granules on the surface of the sun. Hot rising gases cause bright spots to form in the center of granules. Cold sinking gases cause dark areas to form along the edges of granules. Once energy reaches the photosphere, it escapes a visible light, other forms of radiation, heat, and wind. So how does the sun rotate? The sun rotates on its axis like other large bodies in the solar system. However, because the sun is a giant ball of gas, it does not rotate in the same way as a solid body like Earth does. Instead, the sun rotates faster at its equator than it does at higher latitudes. This kind of rotation is known as differential rotation. Differential rotation is the rotation of a body in which different parts of the body have different periods of rotation. Near the equator, the sun rotates once in about 25 days. However, at the poles, the sun rotates once in about every 35 days. Even stranger is the fact that the sun's interior does not rotate in the same way as the sun's surface does. Scientists think that the sun's core and radiative zone rotate together at the same speed. Therefore, the sun's radiative zone and the core rotate like Earth. The Ring of Fire. What is solar activity? Solar activity refers to variations in the appearance or energy output of the sun. Solar activity includes dark spots that occur on the sun's surface known as sunspots. Solar activity also includes sudden explosive events on the sun's surface, which are called solar flares. Prominences are another form of solar activity. Prominences are vast loops of gas that extend into the sun's outer atmosphere. Sunspots. Dark areas that form on the surface of the sun are called sunspots. They are about 1,500 degrees Celsius cooler than the areas that surround them. Sunspots are places where hot convection gases are prevented from reaching the sun's surface. Sunspots can appear for periods of a few hours or a few months. Some sunspots are only a few hundred kilometers across. Others have widths that are 10 to 15 times the diameter of Earth. Sunspot activity occurs on average in 11-year cycles. When a cycle begins, the number of sunspots is at a minimum. The number of sunspots then increases until it reaches a maximum. The number then begins to decrease. A new sunspot cycle begins when the sunspot number reaches a minimum again. Solar flares. Solar flares appear as very bright spots on the sun's photosphere. A solar flare is an explosive release of energy that can extend outward as far as the sun's outer atmosphere. During a solar flare, enormous numbers of high-energy particles are ejected at near the speed of light. Radiation is released across the entire electromagnetic spectrum, from radio waves to X-rays and gamma rays. Temperatures within solar flares reach millions of degrees Celsius. Prominences. Huge loops of relatively cool gas that extends outward from the photosphere thousands of kilometers into the outer atmosphere are called prominences. Several objects the size of Earth could fit inside the loop of a prominence. The gas in a prominence are cooler than the surrounding atmosphere. Prominences generally last from several hours to a day. However, some prominences can last for as long as several months.